Hi there. In this video, we're going to talk about the power of a test. And this is going to be very general, just an overview, kind of introduction to what power means, okay? So let's go for it. We need to be concerned about the power of a test in case we fail to reject the null, okay? So if we were to fail to reject the null, then it's kind of hard to know, was that result correct? Or was our sample size not big enough to detect it? Okay, so that is a big problem. We don't want to do this test and then we're like, right, I don't know. So remember how, and I've got the sampling distribution here, as the sample size increases, our standard error goes down, right? So a smaller sample size gives a larger standard error. So we would need a larger difference. We've got a wider graph here. We would need a larger difference in order to have our difference be statistically significant, right? A larger difference to be significant. Okay, so then we define this concept called power. The power of a test is the chance we'll correctly identify a significant difference and reject the null if it is actually false, okay? So chance of correctly identifying a significant difference, okay? It's also the chance of not making a type 2 error, okay? And so because of that, we use the symbols 1 minus beta. Since beta is the chance of making a type 2 error, the chance of not making a type 2 error is our power, okay? Now the power can go from 0 to 1, since it's a probability, and 80% or 0.8 is the baseline, or is a good baseline. So if a statistician calculates a power of 0.80 or greater, they'll usually continue with the test, okay? So again, the calculation here goes beyond the scope of our course. I just want you to understand that there's a thing called power in case you do see this in the future, and there's a way to calculate it, okay? And then also what I want you to know is the relationship between all these things, between alpha, beta, and the power, okay? That's the main thing I want to focus on in our class. Okay, so factors affecting, not infecting, factors, oh man, that's hard to say. Factors affecting power. Okay, so if we increase alpha, then beta goes down, right? Alpha and beta have a opposite relationship or inverse relationship. If we increase alpha, then beta decreases. So then the power, which is 1 minus beta, goes back up. Okay, so if alpha increases, then the power also increases. Okay, interesting, huh? If we decrease alpha, then beta increases because they go opposite, but then the power is opposite of that, so the power goes down. So alpha and the power, oh sorry, I meant that to go down. I was talking while I was writing. If alpha goes down, the power also goes down. So alpha and the power go in the same direction. Alpha and beta go in the opposite directions, okay? Now, there is one way, and we've seen this one way before, of getting more of what we want, and that is increasing the sample size. That will generally increase the power and decrease the chances of both type 1 and type 2 errors, and that's because, like in this example here, it makes your standard error smaller, okay? So you just have less sample to sample variation. Okay, so that's about the power, just a very brief general overview, but we want to know what it is and just know about the relationship between these different things. Okay, great, thanks for watching. See you in the next video.